back next. I keep talking about next unit. Next unit is just awesome. It's like a great way to end the year. Lots of really cool things come together. We'll come back next unit and we will derive algebraically. We'll just, based on just some simple ideas, we'll derive the quadratic formula. But we're going to practice using it a little bit today, just because it's useful. It gives us some examples of square roots to simplify. Okay. You guys remember the quadratic formula? Give me a 1 to 5 on how well you remember it. Okay, not super well. Okay, so this is it right now. There's two parts to this though. There's people a lot of times remember the formula, and this is like a game show formula. If you're ever on a game show, this is one of those formulas that's likely to be, you got to know it because you might win fabulous gifts and prizes on that game show. There's two parts to it though. This is the formula, right? The formula that the game show is going to ask you about, but it goes with a premise. The quadratic formula only works if the quadratic equation is first put into standard form, right? So this is standard form of a quadratic equation. What's that mean? Well, we just get it equal to 0, right? And write it as a polynomial in standard form. So x squared term, x term, constant equals 0. Once we get it into standard form, then we can plug and chug, plug those numbers into the quadratic formula and get an answer, right? So this is a guaranteed, always works way of finding the solutions to a quadratic equation. As we'll discuss next unit, sometimes there are easier, quicker ways. So we're going to kind of learn to be very strategic about this next unit and pick, based on the problem, we'll pick the quickest, easiest, simplest way of solving it. But this is one that always works. It's just that sometimes it's like a lot of computation. Okay, you guys maybe are having a little trouble remembering this, so I just happen to have a little help for you. Help you memorize this. Okay, I think maybe it seems like I passed this on to Mrs. Robinson, and so you maybe have even heard this before. I realized I forgot to click record on the last example. I wouldn't go through this one, but I want to get one of them on video just in case somebody wants to see them. So let's quickly zip through this one. You did the work. What do you do first? Distribute the x and subtract the 30. Good. You got to, oh, it's frozen. No wonder. There we go. Thank you. There we go. Right, so we get that. Okay. Now from here on out, it's smooth sailing, right? We've got it in standard form. A is positive, so we just identify the values of A, B, and C and plug and chug, right? And what's that give us? You guys did the work. Inside the radical, we get 36 minus 120, which is negative 84. Good. And if we simplify that, so let me add one more step here. So we get, and the square root of negative 84 is going to give us this stuff, right? The factors of 84, the biggest perfect square factor of 84 is actually 4, right? 84 is 4 times 21. And so we can take the square root of 4, which is 2, times the square root of 21. Okay, the I, this time I stuck the I in front of the radical. Doesn't matter, right? Again, books frequently do that, so there's no confusion about whether the I is inside or outside the radical. That's fine. Could go in front or after. And then what's the last step? Yeah, divide each term by 2. And we get, come on, there we go. And we get that, right? Okay. How many answers? Oh, yeah, where'd the minus go? There you go, plus or minus. Okay, good. So 2 answers. Okay, last issue, I just want to show you, and we're not going to really do a ton with this now, but I want you to see it now. We'll talk more about it later. So the part of the quadratic formula, if we go back and look at the quadratic formula, the part that sits underneath the radical So it is the radicand of the quadratic formula, is what we call the discriminant. Because it discriminates between the different types of outcomes we could get for solutions. Can you tell me what value that might have in predicting what kinds of answers you're going to have? Okay, yeah. So look, the b squared minus 4ac, the part that sits under the radical, if that gives you a negative number, you know you're getting i's in your answer, right? So you're getting uh, what will come to you're getting complex solutions with imaginary parts. For now, we'll just call them imaginary numbers. Okay. What if it's positive? I get two solutions then, right? I get two different solutions, one for the plus and one for the minus. Two real solutions, no i's. What if it happens to be exactly zero? Well, not true. There's only one solution because if b squared minus 4ac is zero, think what that's saying. I'm getting x equals negative b plus or minus the square root of zero. Well, I mean, plus or minus the square root of zero is the same thing, right? I'm adding or subtracting zero, which doesn't change anything, agreed? So when the discriminant just happens to have a value of exactly zero, that means we get one real solution only, okay? So just keep that in mind. It's a good tool for making these predictions. And what I would recommend you do is when you're applying the quadratic formula, you always start with the discriminant because a lot of times you'll get questions that'll say find all real solutions. Like a lot of times we're not interested in imaginary solutions. We only want real solutions. Well, you might as well start with the discriminant because if it's negative, you're done. There are no real solutions, right? There's no work to do. Okay. So here's a little summary of what we just said. Here's graphically what that means. If the discriminant is positive, now what does that imply? Well, okay, one thing we know is that if I'm solving a quadratic equation in standard form, right? So I'm solving something like this. Oops, not f. Ax squared plus bx plus c equals 0. Well, there's some function f of x that's set equal to 0, right? Okay, what do we know? We know that the real zeros of a function, which is what these solutions mean. If we have a quadratic equation in standard form, we're asking the question, for what values of x does this quadratic function f of x equal 0, right? So the solutions of the quadratic equation mean the same thing as the zeros of that function. Make sense? Those are the values that make it 0. Okay, one thing we know that's very important, we'll come back to again and again, the real zeros of a function always correspond to x-intercepts on a graph. Okay, so this tells us something important then. If the discriminant is positive, that means that this function that's set equal to 0 has two x-intercepts. If the discriminant is exactly 0, then it only has one x-intercept, which can only happen if the x-intercept corresponds to the vertex. Whether it opens up or down, it's the vertex that's the x-intercept. And then the other possibility, if the discriminant is negative and we have no real solutions, it's a parabola, its graph is a parabola with no x-intercepts. Okay, make sense? All right, you guys can work.